Alright class, we are going to end our unit on section 8.3. This is notes number 43, volumes of spheres. So our main idea, our big idea for today is how to find the volume of a sphere. Now I already have part of it filled out for you, but please make sure you are copying that down in your notes that I have provided for you. The volume, represented by the capital letter V of a sphere, is the product of 4/3 pi and the cube of the radius of the sphere. And I know that sounds really complicated, but it literally just means 4/3 pi times r to the third power, or radius to the third power. Now, when I think about this formula, I think about a circle, because obviously a sphere is kind of like a circle, just three-dimensional. I know that cross section of it is a circle. I know that the area of a circle is pi r squared. Area is 2 dimensions, but because we're dealing with 3 dimensions, I'm trying to fill this up if I'm looking at the volume. I know that it has to be to the third power. So that helps me memorize this formula, the pi r cubed portion. If it's volume, it needs to be cubed to the third power. And then I just memorize the 4/3. It's just a weird number. It's the only one that is slightly, I should say quite different than the ones that we've been looking at before. 4/3 pi r cubed is very unique compared to that of a pyramid or a cone or the prism and cylinder that we have been looking at. So you just need to memorize this formula for now. Okay, I'm not going to worry about deriving it. Product is multiplication, so as you can see, we're literally just multiplying. Okay, so let's take a look at example 1, volume of a sphere. Like I said, I've already started some of it for you, but we can see here that I just wrote down my original formula, the formula that's given here. Volume of a sphere is 4/3 pi r cubed. 4/3 times pi times the radius cubed. I already see exactly what I'm looking for is the radius, 4 centimeters. Starts from the center of the circle all the way to the end. In this case, the center of the circle, like the cross section of it. Okay, so this portion. We're given the radius of our sphere here, so I'm going to input that into my formula. So where I see r, I'm going to put 4. So one thing you need to make sure is that you're not doing 4 times 3. This is 4 to the third power. So that means 4 times 4 times 4. Well, 4 times 4 is 16. 16 times 4 is 64. You could put that in a calculator, or you could simply just memorize it. After a while, with a lot of practice, you will start seeing very common cubes, and this is a common cube that I have seen, and I know you will see it as well. From here, my brain automatically looks at the 4/3 and the 64. It's just something that I know I can multiply by, and I'm going to do 4 times 64. And put that in the calculator. You should get 256 divided by 3, and I'm going to be left with pi here. Okay, so 256 thirds times pi. Let me show you what that looks like in a calculator. I have 256 divided by 3, that's that, multiplied by my pi, which is 3.14, rounded version, and I'm going to get 267.946667. It wants us to put it to the nearest tenth, so when I rewrite that, I'm going to put 267.9. You can see here the number in the hundredths place next to the tenths place is a 4, which means I need to stay the same, so I'm going to keep it 267.9. And this is going to be centimeters cubed, because again, we're dealing with volume. Okay, this is just one answer. It's a rounded answer. I know in your textbook they did not multiply by 3.14. They multiplied by the whole pi, which is a function in your calculator. Some of your calculators don't have that function. So if you want to get the exact answer that they got in the textbook, I would multiply it by 3.14159, and you'll get what they got, which is 268.1. So as you can see, not too far off. 268.1 is very close to this. But if I saw your work on a quiz, I would give you credit for this because you did it step by step. Okay? Let's move on to example 2. Example 2 is dealing with the height of a cone. That's what we're going to be solving for. Very similar to the previous lessons that we've had, finding the height of our cylinder, or finding the height of our pyramid. Now we're going to find the height of our sphere. And I see right here, I have a mistake. I need to fix that in your Google Notes. This is obviously not a cone. This is a sphere. Okay, and again, we're going to be rounding our answer to the nearest tenth. So to do this problem, I'm going to, again, write the formula of the volume of a sphere. So volume equals 4/3 pi r cubed. Just looking at this image, I have exactly what I need. Again, I have the radius, which is what we're looking for, but this is what I'm really looking at right here, is the volume of this specific sphere. So I'm going to take this information and I'm going to substitute it in for volume. V is volume, so I'm going to put that in here. So I get 288 pi. Notice how the answer is in terms of pi, which actually makes it really easy to work with. And I'm going to get 4/3 pi r cubed. Okay, I am literally just copying what I see here. The only unknown that we have is our radius, and that's what we're going to be solving for. So some of you look at this and you're a little confused, but just know one thing that I can do is I already know, just looking at this, that I can get rid of my pi's. I know I'm doing multiplication here, so I'm going to divide by pi on both sides, so I can just get rid of that. I don't have to worry about it anymore. I know pi divided by pi is 1, pi divided by pi again is 1, so I know that cancels out. Now I'm dealing with just numbers. So I have 288 equals 4/3 r cubed. Okay? Anytime you see a fraction multiplied by, in this case, r unknown, you can divide by the fraction, so divide by 4/3 on both sides, or like you've been taught before, is to multiply by the reciprocal. So I'm going to multiply this by 3/4, and whatever I do to one side, I have to do to the other side too. So I'm going to multiply by 3/4 on both sides. Now, some of you, again, are going to look at this like, oh, I don't know what to do with this. But what I've said before is anytime you have a whole number multiplied by a fraction, put it over 1. Now you've made it into a fraction, so it's easier to look at. Okay? I'm going to multiply 3 times 288. So I'm going to show you what that looks like. 3 times 288 is that 864. Then I'm going to divide by 4, which is 216. So I get 216 equals r cubed, because 4 times 3 is 12, 3 times 4 is 12, 12 divided by 12 is 1. It cancels out, or you could just cross cancel. 3 divided by 3 is 1, 4 divided by 4 is 1. It's gone, it cancels. Okay, this is using the reciprocal to cancel out this fraction here. Okay, now we haven't really seen this yet. This is actually going to be more next unit. But what this is saying is r cubed equals 216. So a number multiplied by itself 3 times is 216. Some of you can do that in your head. Some of you have that memorized. But this is what it looks like if you want to get rid of that cubed. To get rid of a cubed, you have to take what's called the cubed root of that. So I'm going to do that off to the side here just so you can get an idea of what I'm talking about, a preview of the next unit. I have r cubed equals 216. And if I want to get rid of that cubed, I'm going to take the inverse of it. The inverse of a cubed is taking the cubed root. Now that cancels and I'm left with just r. But again, whatever I do to one side of the equation, I have to do to the other side. So I'm going to take the cubed root of 216. Now, what this means, it's very similar to what I just said, means what number times itself 3 times is 216. Again, you may have this memorized, you can look this up online, but that number is going to be, I don't know where I wrote to, is going to be 6, because 6 times 6 times 6 is 216. So I'm just going to rewrite that over here. R is 6. But look at our units, we have inches cubed. So because I have inches cubed, I'm just going to put inches. Our radius is inches. Okay, our answer here is 6 inches for our radius. Okay, I know that's a lot of math going on here, so please feel free to message me any questions that you have. Again, this is not a cone, this is a sphere. I need to fix that on your Google Doc. But this is one way to do it, class. There are different ways you can do it as long as you're following your order of operations and knowing your commutative properties of multiplication. Okay, I'm going to go ahead and flip it over. This is where I'm going to ask you to show me your work for this. I will provide you the answer. You're going to put your work into your Google Slides for me. Make sure you click Turn In when you are done as well. But these two problems are going to require you to find the volume for this one or the radius for this one. And we're going to round our answers to the nearest tenth if necessary. Some of them may not be necessary. But our answer, just so you can see them, see if you're right. For number one, the volume is going to be 2,048 divided by 3 pi. Okay, that should be your end result. And it's going to be the same thing as, or about the same thing as 2,144.7 feet cubed. Okay, that is the answer to this on your own. So if you didn't get this answer, there's something wrong. Okay. Number two is going to be our radius. That's what we're looking for. Our radius here is going to be 3 meters. Okay. So again, if you don't get that, you need to redo it, ask for help. Please ask me, ask your parents, ask your friends, or even look it up online to see how you can do that. Okay. All right, let's move on to our last example. Then I have some practice problems for you guys again to look at. We're going to look at this real life application problem. Just means it's a real world problem, something you may see in the real world. It's a picture of a silo, and it says a hemisphere is 1/2 of a sphere. And you guys know that a hemisphere is just a half of a sphere. So it's very similar to a semicircle. A semicircle is half of a circle. A hemisphere is half of a sphere. Okay. The top of the silo is a hemisphere with a radius of 12 feet. Just because I know some of you are curious if you don't know what a silo is, it's obviously a large container that helps store different things for farmers, maybe, and that could be like grain. It's a very common thing that you would see in a silo. Okay, so the top of the silo is a hemisphere, so we have right here, with a radius of 12 feet. So they tell us here that the radius of this silo is going to be 12 feet. What is the volume of the silo? And we're going to round our answer to the nearest thousand. So notice it's different than our hundred, to the nearest thousand as in a whole number. Okay, no decimal here. So I know from previous sections that the volume of a cylinder is going to be area of the base times the height. Okay, so I've split this for you. This part of it is a cylinder. This part is a hemisphere. Okay, so this should be review. The area of our base, well, hopefully you can recognize a cylinder that it's going to be a circle. So the area of that is going to be pi r squared times our height. Okay, they told us that the radius is 12 feet. So I'm literally just going to input that into my formula. It's pretty straightforward. So I'm going to input my 12 feet here. So 12 squared times our height. Our height here, I guess I should label this. This is our radius. This is our height. Okay. I'm going to input it and multiply it by 40. Okay. And just for the sake of time, I'm going to tell you what the answer is. It's going to be volume equals 12 squared, which means 12 times 12, not 12 times 2. 12 times itself is squared. So 12 times 12 is 144. 144 times 40 is 5,760. And I'm going to leave it in terms of pi. So 5,760 pi feet cubed. Okay, now I'm going to look at this hemisphere. The formula here is 4/3 pi r cubed, but we have a problem. We don't have an entire sphere, and this is the formula for a sphere, not for a hemisphere. So if we want the formula for a hemisphere, we got to take this and divide it by 2. You gotta take half of it. You could take this and multiply by 1/2. It's the same thing, but I think some of you are more visual when you understand you have this. Divide it by 2 because it's a hemisphere, half of a sphere. Okay, so I'm gonna note that for you. This is for half of a sphere. Okay, we have to divide by 2 here. So again, my radius is 12, so I'm going to input that. This is our radius. And we're just going to, like I said, input that into our formula. So 4/3 times pi, our radius cubed. Well, our radius is 12, and it's going to be cubed. And then I'm going to divide this whole thing by 2. Okay? 4/3 times pi times 12 cubed. I'm going to do that first, my numerator. 12 cubed is 12 times 12 times 12. So I'm going to show you with my calculator here. I have, actually I can show you this way. It's easier. 12 to the 3rd power is that 1,728. I'm going to multiply by 4. Okay, 6,912. Divide by 3. And I get 2,304 pi, 2,304 pi, and I'm going to divide by 2. So I'm going to divide that by 2, divide that by 2, and I get the volume equals 1,152 pi. Okay, again, I left it in terms of pi. It just makes this next portion a little easier. So I have the volume of this portion, and I have the volume of this portion. Now all I have to do is add them together. So, I'm going to write this out for you. The volume of the silo equals, I'm going to write our answers here, 5,760 pi plus whatever this is, 1,152 pi. Okay, and if you put that in the calculator, you're going to get 6,912 pi. Okay, but it says to round to the nearest thousand, so I know that I have to multiply out 6,912 times 3.14. So let's put that in the calculator. 6,912 times 3.14 is going to be that number, 21,703.68. It says to round to the nearest 1,000. So here's the thousands place. I'm going to look at the number here. It's a 7, so it tells me I need to round up. So our answer is going to be about 22,000 feet cubed. Alright, and that is the volume of our silo. I'm going to now show you the very last thing you need to look at, and it is going to be our practice problems. So I want you to practice finding the volume of these composite figures. Remember, composite just means that there are different figures put together. So here I have 2 hemispheres in a cylinder. I have here a cone and a cylinder. Okay, so for those of you that want to check to make sure that you're doing it correctly, I'm going to give you the answer to these on your own. But again, I want to see your actual work for it so that I know and you know that you're doing it correctly. Okay, but before we do that, let's make sure you are writing your formula down. The volume of hemispheres, oh, you got 2 hemispheres, I should say, so 2 hemispheres is 1 sphere, so you can write the volume of that. Volume equals 4/3 pi r cubed. You don't have to worry about dividing by 2 because you have 2 hemispheres here. So I'm going to write that right here for you. 2 hemispheres equals 1 sphere. So I don't need to worry about dividing by 2. Okay, and then I have the volume of a cylinder here, which is going to be the area of the base times the height. Okay, And then for this one here, I have a cylinder. So again, volume equals area of the base times the height. And the volume of a cone is very similar, but it's going to be 1/3 times the area of the base times the height. Okay, so this is for the hemisphere, this is for the cylinder, this is for the cylinder, this is for the hemisphere. All right, and the answer to these problems, let me make sure I have the right ones. Okay, I found them. The answer for number 3 is going to be 80/3 pi, which is about 83.8 inches cubed. Okay, and then this one is gonna be 96 pi, which is about 301.6 meters cubed. Okay, so just so you know if you are on the right track or not. All right.